Alrighty, friends. So we have just finished our survivor game. Hopefully, you were one of the lucky ones and you are still alive in this ecosystem. Sorry if I accidentally killed you in our game, but all in good fun. So, this game was a way for us to think about how the choices, not choices, the adaptations and evolution of particular species cause them to reproduce, to find food, to eat in a particular way. And those variations serve them in different ways in terms of their survival. So we're going to go through some of the different classifications that you should have learned for homework, go a little deeper, and make sure that we have that context before we go back and revise our work. So again, the important vocabulary here is generalist species, specialist species, R-selected species, and K-selected species. Generalist versus specialist, it is exactly what it sounds. A generalist can survive more generally. A specialist specializes in a particular way. So this typically refers to two things. One, the type of habitat that they occupy, how specific the needs are for them in that habitat, and the number of sources in which they can obtain food. So for instance, brown bears can be found pretty much in any deciduous forest or taiga forest throughout both Europe and the United States. They are known to be omnivores. They can eat plenty of different fruits, vegetables, and meats, and even scavenge through human trash to find food. On the other hand, you have the koala bear, though not really a bear, a marsupial. Koala bears eat only eucalyptus and can only live in a very select number of habitats throughout Australia where these eucalyptus trees are available to them. And so they would be considered specialists. They are very well adapted to that particular ecosystem. So assuming no changes in that ecosystem, they are likely to survive. But a generalist tends to do better in a changing environment because they can adapt and find different sorts of food or potentially move to a new ecosystem. Okay, so we can further think about this in terms of whether species are K-selected or R-selected. Now, you can have a generalist that is K-selected and a generalist that is R-selected. So these factors are separate from each other, but another way to classify. So why K and why R? So you'll notice the K is always capitalized, the R always lowercase. This is because they represent some conceptual things that determine how the population grows. K represents the carrying capacity. You'll remember carrying capacity is the maximum number of organisms that can live in an environment. So in a particular ecosystem, it might be that 100 elephants can survive there based on the availability of resources. So it is limited by things like the amount of space, the amount of food, or the amount of water, etc. So the thing that determines the size of these populations is typically the environment, which we use K to represent that carrying capacity. R represents something known as intrinsic growth rate, meaning in an ideal condition, how quickly could a species grow? These graphs are often exponential because as the species starts to grow, they reproduce even faster and faster, and the numbers shoot up. R-selected species reproduce very, very quickly, so their numbers shoot up exponentially. So the fish here is an example of an R-selected species. This is, of course, under ideal conditions, and at some point, R-selected species tend to experience overshoot, where their numbers overshoot or move past what there is space or resource for, and they experience a die-off. So rather than maintaining a stable population size like a K-selected species might do, R-selected species tend to have a spike followed by a die-off, and this cycle repeats. All right, so let's take a kind of big picture step back look here. Hint, hint, you might want to have some of this in your notes. K-selected species tend to live for a long time, relatively speaking. They also take longer to reach maturity, meaning the age in which they could sexually reproduce. They tend to have many reproductive events over the course of their lifetime, so they have several opportunities to bear offspring, and those offspring are often large in size. So if you think about many mammals. Most mammals are K-selected with a few exceptions, and they tend to be large. Not all K-selected organisms are large, but it is most often the case that if an animal is large, it is K-selected. These organisms also provide parental care, meaning that there's a period of time post-birth where the organism is unable to survive on their own and needs a parent for some portion of its life. As a result of the need for parental care, there is typically few offspring born at one time and large spans of time between reproductive events. Therefore, the population does not grow very quickly, and it is the density of that population, or how many organisms live in a particular area, that carrying capacity, that determines the potential growth for the population. Because of all of these things, slow growth size, parental care, populations don't tend to experience overshoot. They tend to stay pretty stable near their carrying capacity over time. Your R-selected species, pretty much the opposite, often do not live for very long. They reach maturity quickly, meaning they are often not very old by the time they are able to produce offspring. Because they have short lives, the number of times that they give birth in their life is likely not that many. Or in the case of an asexual organism, the number of times that they reproduce asexually. There's often no parental care, or what is available is really, really limited. And again, because these organisms typically have many offspring at a time, because they don't have to provide care, right? If you think about your parents, they need to spend a lot of time with you to keep you alive when you're a baby, so they can't have more than a few of them. If your parents didn't have to spend time with you, they could potentially have hundreds of offspring if they could just be left to their own devices. So you see this with a lot of egg-laying amphibians, fish, insects, etc. The number of organisms in the population doesn't typically reduce the size or its growth. It's more so things like a fire or a change in the environment, an increase in the pH, etc., that could cause large die-offs in population size, or if they experience overshoot. For all of those reasons, the population tends to follow moments of exponential growth followed by die-off, where the population size changes really rapidly. So our selected species are often not very stable in their population numbers. The final thing to think about is that R-selected to K-selected is a continuum. It is not a simple, an organism is just R, just K. Often you have somewhat of both. So rabbits tend to sit more on the R-selected side. They have many offspring, lots of them die, and they don't provide a lot of parental care, but certainly more parental care and are more affected by carrying capacity than, say, the bacteria on our far left. Birds, right, provide some parental care, more than a rabbit, but certainly less than a human might. Most birds would leave the nest of their parent after a few months and begin to be able to be independent. But many birds do not lay more than a handful of eggs at a given time, right? So you see this continuum, and most species tend to fall somewhere in the middle. So we're going to go back now and look at that response now that we have deepened our understanding of the differences between generalists and specialists and R and K selected species, to think about which classification of organism is most likely to survive in a changing environment.